Okay, perhaps we can start the session because I guess not many would come, but as I said, the fellows have to be here, but they're not here. None of them here, but it's okay. She told me, can they attend? That yes, we have many spaces. Okay, but it's fine. Anyway, I sorry that I don't know. Lin Yu Chang, Dr. Lin Yu Chang, but your name, she or you. Okay. Then you can introduce yourself again because when that. But this is a special session that Kylie from Dr. Chang to give us the training that using the QGIS, which is sorry, with open Q. Yeah, and then this is the one that Dr. Nopadon, you know him at NECTEC, he using for AgriMap development as well. Try to update because the problem we have that to update the new information into the system, we have all the GIS layer, have everything, but to update is very difficult. So the satellite can help in some extent, but still you need the few data as well. So Dr. Nopadon, the next he tried Kilipat, I think Dr. Nopadon Kilipat, he tried to mix up with using the Q open queue. That I think you met him before, right? Yeah. That's why I asked him to come and present it in agriculture. He usually come, but he said, "Oh, he already here. I don't need to because you know a lot more than him." So please, the floor is yours.
Nice to have everyone here, and I'm come from Taiwan Space Agency, TASA, and my name is Liu Zhang, and this morning I'm going to introduce DataQ, maybe I should say Open DataQ, ODC, to over here, people here, and maybe because our schedule is arranged like we have 1 hour's lecture about what is the ODC and what is the content in ODC and basically how we use that and some of basic applications. And actually, that is for first hour. And then the next 2 hours actually is the hand-on practice. I will show you we will share our VM to each other, can have practice on actual operation of our VM. Of course, we will give you some examples to practice with. And don't worry about that. We will ask you to write program. Yeah, we have sample code over there and let you to run and see what is the interaction and the response of our OpenDQ, and let you have a very basic idea of how we can operate ODC. And as introduced just by very time, right? I don't. Yeah. Dr. Nopada used our system to develop the rice distribution for whole Thailand. I have to. Yeah.
The real practice, nah, you can see that the people install a lot of they have application, but the farmer, they are like me, old people, you know. So after register, they not follow up. That's the problem. Is so this is one thing that how you have technology, you have everything, but how to get the people, the farmer, using it.
Yeah.
You know, if not, it doesn't mean anything. So that's what the Dr. Don trying to do, but that's the problem.
Yeah.
That cannot solve.
Yeah. Actually, we have this kind of trouble before. As long as we have, actually, we have to build a bridge between the system and the farmers. Actually, which is notification systems and that. And we don't actually, you can expect the farmer can directly go to the ODC and do something. And actually, we make a web page to notify the result from in ODC or the most current farm, how to say that, rice field information, and through a notification system to let the farmer can know the real situations. Maybe for some example, especially in Thailand, the land is so huge, total different from Taiwan. yeah. You maybe you have not much chance to, I mean, manually patrol to everywhere every day. Yeah. So we use satellite information to replace this part and hope then as soon as we find something's real, and they can just go to that specific location and see what happened, something like that. So that is a notification system.
For mangrove, you can use that too, because we're trying to do that. We talk with the Global Mangrove Watch. So in Netherlands, they're doing for us now, but they're using Sentinel only. But the problem is that because of the cloud persist in the mangrove area. But we have to do ground check for them. This is for the Department of Coastal, Marine and Coastal, just helping out. So they have that too, but still with the cloud, they have a problem.
I think that the mangrove actually should be distributed in around coastal area or the river bank or something like that. So I think that maybe we can try to use the radar data, something like that. Yeah, I can see through the cloud, and then maybe we can have something. Actually, there is already research about this part. So I think we can implement this part in the future, or in the next, not in the future.
For Eric wrote for forest fire, that can use the OpenQ.
Oh yes.
Yeah, and then that can be operation if you could try. I also act as still advisor to the Director General of the National Park. So if the system can be in place, and you can test it out. You can test it out, and for the forest fire, whatever, like a burn area or the progress of the fire. Right. Because but Afoco is working with Royal Forest Department, different department. But it's okay. It's okay. Can mix up with everything. Yeah. For Afoco Korean, they're doing only forest, but in 15 countries. So that's why she's here. I asked Susin to be here.
Okay, actually, we already have forest wildfire example.
Okay.
Maybe if we
that's one. The wildfire is one of the topics for Afoco.
Even we can forecast that if there is potential to have wildfire, because before the fire happened, everything dry up.
Yes, but the problem is that the people light it up. Not like in Australia, they use birds. The Black Hawk or something that they light the fire. I mean, they take the fire to another place. So after the fire happened, they hunt. Like wow, the birds. Yes. In Australia, only one species, foci, I think, but one's hawk, something. One of the hawk, they call Black Hawk or something, Fire Hawk. Yeah, there's only one species in the world that can accept, rather than us, that use fire to hunt. Like really? Yes, in the world. Right. Very surprised. Not very surprised, but people like cannot believe it that the bird can do it.
Just a reminder about the but according to the program this week in general, we have 30.
Okay. Okay, 10:30. Please remind us. 10:30.
Right. Okay. And okay, I'll announce it here before, because I already told Shan this morning that the cruise for the bus we'll leave at 5:15, but we have 6 buses and the van, but 6 buses, and when you full one bus will leave, so we don't, other people don't have to wait for everybody. First we asked to get the director Bama Uninet, asked the police to come and lead all the thing because of the traffic thing, but now change because everybody not everybody doesn't have to wait for it, to leave together. So when the first bus full, go up, and the cruise will be from 7 to 10, extended 1 hour last night. Also, director of unit called somebody, and the company extended. So be back at the hotel around 10:30, I guess. Yeah. But when you go early, on the pier, there's a antique mall. Yeah, nice one, expensive one for the antique. You can walk.
Okay. Okay, let's go back to our schedule. Okay, actually, this is our schedule today. Okay, actually, that is totally 3 hours, but I think that we can make it more flexible. Yeah. I think that maybe at the very beginning, we can just carry out our lecture. Okay. And also, we can wait for more people to come. Yeah. And then the next two, maybe the most important one, that, like I said, the hand-on practice for our ODC. So that can be included in 2 parts. One part is fundamental applications that is about to introduce you how to use ODC in very basic way. Because you know, Open Data Cube is consists of multi-sensor, multi-temporal images. So, for example, especially for optical image, for one sharp image, there may be clouded over there. But if you can integrate a period of image, then select those pixels without cloud. If you can make proper integration, then you can have a cloud-free image, something like that, with a suitable tempo. That depend on your research. Right? For some purpose, you allow to have an image within 1 season, for example. Then you have a very good chance to have a cloud-free image. It's very small optical image, because sometimes this is very unlikely. Yeah. Yeah. Oh, okay. Okay. Since you asked this one, this is actually a tough question. Yeah. Actually, I think about this one because Google engine actually is too strong. It eventually, I mean, almost can do anything because there's more than 400 layers over there. Yeah, including remote sensing image and the derived information. Not only the satellite image itself, there's also including a lot of derived information from that is already in Google Engine, because Google Engine cooperate with many universities and agencies, so they have many kind of derived information. For example, soil moisture, something like that. That you cannot get that information directly from satellite image. You have to make some calculation and combine different sensors information. Then you can have soil moisture, something like that. Okay, so for my point is that most of people using Google Engine, that is because it is free. It is free, right? But in Chinese, we say that the things are more cheaper, but eventually you will pay more. I don't know how to say that in English, but sometimes we have some kind of thing. Yeah.
Good example for the ESRI. When they started, they distribute all the ArcGIS for free. So all the students at the beginning using the same, only their software. And then they shot.
Yeah. When they get to the company, yeah, the only thing they know is QGIS.
Oh yeah.
Yeah. So that's why. So when you really need to do a serious analysis, this is an example. We need to use the very original satellite image or something like that. But when you're doing this kind of things, you need to, you need to obtain a lot of information from Google's. But actually, the data amount is limited. You will find that since as long as you want to, make real calculations or research, you need the real original resolution data. Then you will have this kind of problem. So my solution is, because I also use GE, so I just take a little part of the image and make it many times, and then aggregate everything in my local system. Then I can have the very original source image and do my research and get how to say that, not only for demonstration but really useful result for our government officers, because you cannot say I can only go to the country levels analysis. Actually, they need county level or each cities or each how to say that, petty fields information. So you cannot get them only country level information, especially in GE. They have an area to let you write your program. And when you zoom in, zoom out, the result will be changed also. Yeah. But the problem is you never get into the original data. Okay. But in our data cube, that is total different story. You always use very original data. Yeah. And but it won't waste your time, because the whole calculation is on cloud computing environment. You won't get the result back to your desktop GIS in your home, something like that. So you won't waste the traffic for the internet. And but for Google, if you use Google engine and you are going to carry out a serious research, then you have to get the information back to your home and to do everything. So you have to do that small chip by small chip. Yeah. And my experience, even you do that part by part, a small one by small one, eventually the total amount of the data amount, there is many limitation over there. How much amount you can get at once, and within specific period, how large amount is another limitation. So eventually your research will break over there. Yeah, and wait until tomorrow or next week. Yeah. We can count on that part. Yeah. So my choice. So this is different. How to say that, business model. I don't know how to say this. Actually, we have this is our differences. Yeah, this is our difference. But maybe I can say more about this one, because not only for Open Data Cube, not only a very original data you can use every time, and there's no limitation. And you can also, we provide a code that you use our ODC to connect to GE, and you can use those data retrieve it to ODC and combine them together. The coverage, yeah, for ODC, right? Yeah, that is depend on user. If you like to use the whole Thailand area like no pattern, then we prepare data for them. Yeah.
Also host it for Australia, but no, they coverage up to Indonesia only. Australia, Indonesia, not up here. So
that depends on the scope of the research project. According, of course, for Taiwan, actually, when we cooperate with Dr. Napata, then Taiwan is very easy now. because Thailand is 14 times larger than Taiwan. So and very original. Taiwan is not that easy for us. Maybe, yeah. Yeah. Right now, the whole Thailand's data is already in the ODC. So no. Yeah. Okay, that's another point. We would like to share the data already there to everyone. Yeah.
Online, so that's why I thought, oh yeah, okay, somebody online. I didn't know. Sorry. So if like something like that, so we can start at the HII Hydroinformatics Institute to try to use that, try to integrate it into the operation that we do.
Yeah. So right now for whole Thailand's area's data, not only Sentinel-2 data, but also Sentinel-1 data is over there. Yeah. So maybe cloud is
because she's doing for JAXA.
Oh.
But JAXA is like small part in Suphanburi, I think. Yeah.
Okay.
But Sobue, they can, orbit. They order and then collect data, and then she's making all analysis.
Okay. But JAXA has ALOS.
ALOS,
and that's aeroplane radar data, maybe have better penetration of the trees, something like that. Okay, so that maybe have different kind of applications over there. Okay, so okay, this is about the first part. I mean the schedule of our hand-on practice day. So okay, let me go to my first presentation. Okay, ODC system and the capability. Okay, actually, this is a brief introduction of our ODC systems. Okay, and okay. So maybe at the very first, I'll give some introduction of DataCube and then service framework of our DataCube that is already in Taiwan. And then I will say something about maybe the next version, next generation is a little bit ambitious, but actually next generation, there is many modifications over there and making more compatible with, for example, OGC standard, something like that, better connectivity with other GIS, geospatial systems, something like that. Okay. And so about the introducing of our Taiwan DataCube, and we will say something about the stuff over there. For example, Command Line tool, set that data in ingestion, and DataCube Explorer, Jupyter Notebook, something like that. Okay, I will make very brief introduction about this part. Okay, and then I will introduce some applications has been carried out that support the SDG, Sustainable Development Goal in United Nations. We have some application developed for SDG, and maybe you can use that kind of demonstration to understand what we have done there. Okay, this is the first one. Okay, of course, why we need to have a platform to handle our data, because the data there is growing very quick. Okay, so we need to have a platform, and not only using the file-based system to manage our satellite image. We need to have a platform, and since you make your query according to spatial or temporal information, then your data should go to some variable of your program, not just give you a lot of file and then you have to naming it. Actually, sometimes because you have many data, naming is an issue already. Okay, so So right now, the ODC, the platform, the purpose is to let the query the data to be available in your code, and then you can directly operate in your following modules, something like that. And the variable is kind of a 3D variable, right? Then you can operate spatially and temporally together. Okay, this is why we need to have a platform, because the data is larger and larger. Next one. Next one. So actually, ODC is not devised by ourselves. Actually, that is continually promoted by CEOs, Committee on the Earth Observation Satellite. And because they want to share the different kind of data, especially share data more conveniently, so they establish this kind of a service to promote the data cube, especially the data cube. Actually, in the world, there is many different versions or people doing data cube. For Germany, there is some people doing their own data cube, but for our part is from Geoscience Australia. From Geoscience Australia, actually they made the ODC. Actually, they say they spend a lot of money to do the ODC, and they are very generous to make it open source so everyone can get the software and install software to manage their own data. But of course, to install the software is not that easy. Yeah, not that easy, because that is open source. The documentation actually is not complete. So actually, we still have to pay our times to make a gap between the installation process. But it's okay. We already finished this part, and so for the purpose of the all main objectives of the Open Data Cube, first it is a data warehouse. Yeah, it is data warehouse. Of course, you can use can store a multi-sensor, multi-temporal data, and because your data is spatially and many time data over there, so that then we will have a cube data system. So we call that data cube, and of course that is in cloud computing. We need to have maybe you can. I mean, a better way to operate this one is to put your system in a supercomputing environment. That's what we have done right now. But you also can install that in your local Ubuntu system. This is also okay. Okay, it's also okay. Okay, and all the data in the system is analysis-ready data. Why we say the analysis-ready data? Because for satellite image, as you know, normally after the data is just acquired, you need to have a lot of pre-processing. For example, radiometric processing or geometric processing, something like that. Everything has to be processed. Then your user can use that data without many considerations, of course. So in the standard of ARD, especially for optical image, it should be surface reflectance, not the original radiance, something like that, or even gray or digital count, something like that. That is not that good for the end users, because the end user won't know in very detail for the data processing chain over there. So we have to provide them the data, kind of data is calibrated and processed, and then can directly use in their module, and the data should has temporal consistencies over there. Then they can have the result, right, something like that. Okay, so the last point is what I said. The data is should be performed as data cube should be performed like a service provider to provide data from services not from file. Okay. Okay. So the user can directly operate data in their modules, something like that. Okay. Next one. So as I mentioned, for our data cube actually is installed in supercomputing environment that is provided by National Center for High Performance Computing, NCSC, that belongs to NALAB of Taiwan. And because they are specialists in doing cloud computing, so we rely on their system and put all of our computing environment and our data in their supercomputing environment. Actually, this we call that Taiwan NEAR 2, and they call the service Taiwan Computing Cloud, TWCC. So our one is Taiwan Data Cube and TWC, and they are TWCC. So these two systems combine together to provide a service, ODC service for everyone. Next one. Okay. So right now, the service framework of our Taiwan Data Cube is like this one. We have a different kind of data. For example, our formal set series data, and also the open source data like Lenses series and Sentinel series data. Okay, especially for Sentinel 1 and 2, we archive all the data just from their launch. So actually right now should have many years data, and of course our formal set data also is there, but for this far only limited in Taiwan. For different countries need them, maybe we can have a talk and to integrate your country's data over there. For example, for the Thailand's data, because we have project with NetTech, in Dr. Nopada in NetTech, and so we already integrate maybe several years data for Thailand areas that is directly ready to use. And of course, if you have the data already there, then you can prepare them as ARD. Of course, for those open source data, they are already in their ARD, so that can be ingested very straightforward. And but for your own satellite, you have doing the ARD by yourself. So actually, right now we have kind of SOP to process our formal set data to be like ARD and can be ingested to Open Data Cube. And but for Thailand, okay, CSV image actually right now we are collaborate with GSTA to help them process their satellite image, CS image to be ARD, and then can be properly can have better performance in ARD to serve all our people here, especially Thailand people. Of course, if you have ARD or temporal ARD, then you can do a lot of things. For example, you can extract the time series data to your module and make a kind of analysis. Sometimes we call that is there's another name called phonological profile. You can create a phonological profile and try to identify the ground information. Yeah. Okay. So next one. Okay. So in our Taiwan Data Cube and the work in TWCC, Taiwan Computing Cloud. Okay. Of course, I have many. Right now we have a part of operation right now is in the Academia Senior. Okay, that is the facility provided by Eric. Okay. Because right now we think that not only NCSC but also Academia Sinica is very important source provider, and they also operate our ODC more conveniently to all people. Yeah. So for our TWC and TWC, actually we divide them into two kind of cubes. The TWC actually is composed by many cubes there. some of the cube that is responsible for data itself, but some of them is responsible for application itself. Especially for application service cube, that actually is the one we deliver to users, let them to operate their module with the data prepared in our data service cube. Of course, in this manner, user can also ingest their data into the application cube to serve them to different people, something like that. Okay, so this is kind of for how to say that, another kind of business model. The user using ODC not only can open their data, but also can share their finding, okay, maybe the result of their module, and share them to others. Yeah. Okay. So next one. Okay. So the next one is the next generation TWC framework. Of course, right now in virtual machine, there is a very good structure. So we call that Docker container. Okay. So in that way, we can manage many users within a cube, then make the utilization maximum utilization is something like that. Okay, because in the past, because of the security problem, we deliver a specific VM to each users. For that specific VM, there is a data cube over there. But for, as you know, a VM, for a VM, its core number or its memory setting is already there, cannot be changed very flexibly. But if you can, but as you know, not all the VM is running at the same time. Just that every VM is said. For saving energy, right? You have to dictate which VM is in use and which is not in use, something like that. So right now, there is another scenario is only one VM, but with many cores, or focus all of your cores in one VM and use that container to separate users and solve the security problems. That is that container structure. And the Jupyter Hub scripting structure is also the same manner, because original Jupyter notebook, the security is not that good, because different users actually can see each other's content through Jupyter notebooks. But so right now, in order to solve this kind of management problem, so we use Jupyter Hub that can provide users with a standalone or maybe not isolated scripting environment to let them write their program securely. That is Jupyter Hub. And the OGC WNS data structure also supported by the new TWC framework. And the user can provide their results or use the data we provided by OGC standard. For example, WNS data structure, they can just pull the data through WNS standard and get the image be seen or be operated within their local GIS system, something like that. Okay, so this is the new generation. Let's skip this one. Okay, so next one. Okay, okay. Of course, there's a command tool to let you put your management statement through the VM directly. Okay, next one. Okay, this is for a data ingestion process. You can ingest your data through the command line. Next one. Okay, and you can also the new version TWC, you can browse your image directly from the web-based interface prepared by the TWC, but actually ODC. Next one. Okay, talking about the function tool and TWC, of course, sometimes, most of the time for the programmer, they need to use Jupyter to write Python code. in to do their analysis. And of course, okay. So for the data, because like I said in ODC, all the things after, all the data after your query, every result should come to your variable. So in the TWC, the variable will have different kind of layer over there. For example, if the query the data is temperature or precipitations, then you will have a 3D three dimensions variable over there, and another one will also be there, and this is the location index over there. So the whole this kind of data structure called X-array. Okay, and if you after you are querying, then all the query the result will goes to X-array variable. Then you can use X-array command, or then you can retrieve the whole any data about the query information. Okay, this is the Jupyter Notebook. Jupyter Notebook under Jupyter Hub is okay. Let you write your program here. Next one. Okay, this is the measurement part of Jupyter Hub. Then we can know different use the using status. Okay, or the usage of different users. Yeah, next one. Okay, this is a very important one and very a very good advantage using new version ODC. You can just using your QGIS, something like that, but I think QGIS is the same. Just connect our ODC by Darian's standard. Then you need not to write any program, and need not to install any plugin, something like that. Then you can browse the data in the ODC, or even use the data in ODC and make your connection more easier, something like that. Okay. And for example, there is actually this an example will be included in later hands-on practice. And the user, we will teach you how to set up a connection to our ODC and query the image and display it in your QGIS. So, okay, this is the same thing. We can from the QGIS, and you can get the link of the direct service and just show the image. Okay. Maybe I already used a lot of time. Okay. And but it is okay. And that is the application, or some application has been carried out in TASA. For example, we have the ODC application with Thailand that is below NetTech STDA to do the petty rice, but also sugarcane, I think, distribution analysis. And of course, this is research in Taiwan used to know reservoir water quality. And of course, we can use our optical sensor to know the bathymetry situation for some shallow areas, something like that. Okay, because especially for the island area, the coastal area, the bathymetry actually is not that easy to measure by the kind of sounding systems, because the ship is very large. It has different difficulties to go to the shallow areas. So in this kind of applications, we can use that to the right bathymetry. information. Of course, the coastline change is also not that difficult to carry out. And that is for environmental monitoring. And for disaster identification, for that we have oil slick detection, wildfire detection. No, actually, that is in collaboration with Paraguay Space Agency, because in South American areas, because they have this kind of wildfire situation. So we use satellite image to detect wildfire for them. Okay. Okay. So maybe I can go more deep for some specific applications. This is for total suspension matter. That is water quality application that we carry out by ODC. Normally, if we need to have for water quality, for example, total suspension matter, we have to take a boat and make a field survey and retrieve the water there. And then when you back to the laboratory and see how much dirt or unwanted material is contained in that sampled water. And then you have to go to many sites to do these kind of things. And then eventually what you have is a point result for sub-specific locations only. Next one. But if you use satellite image, you can have a whole series of data. Okay, in the case here is 1 year's data of Sentinel 2 and plus some Formoset data. Okay, next one. And by using the field survey result, we can make a regression model to retrieve the TSM, total suspension matter of the water over there. Because from satellite image, especially optical image, for a shorter wavelength band, for example, blue band or green band, if there is some of the particles inside the water, you will get more refractions. If there is no any particle there, only pure water, because pure water is will absorb most of radiance, so you normally you won't get any refractions, and that means the water area, clear water area, will looks in very dark areas. But if you have a particle or dirt, something that inside the water, you will have more radiance refracted. So in this case, we can have make a model to know how much dirt or total suspension over there. Okay, so right now the reddish color means there is more. Can I say pollutant? Okay, maybe particles over there. Maybe most of them should be same over there, and your water become not that clear. Okay, the reddish area. But you can see that from the result here, you can only see the winter area is dirtier than the summer area. Next one. It is not quite good, because so we just import all the rapid result to our data cube again, and then we can query for specific area and its TSM variations. In this case, then you will know in which time period it is dirtier, and some period it is cleaner, something like that. Then you can have a time series of any location of your reservoir. This is very important. Your field survey can only get your point information, and you also have to make a lot of effort to go to the field. But if you use satellite image, you can get area result of your parameter in interest. For example, in this case, is TSM. Next one. So we can, in this case, then we can know different places and different TSM distribution. For TSM distribution is a very temporal distribution for different places. For example, for the people operate the reservoir, they want to take water for people use. So they need to find a place that is always clear for the whole year, something that, for example, for some places it may be clear for some time period, but not that clear for another period. So from the analysis here, because we are already carrying out the whole year's analysis, so they can find where is the places that is clear always, something like that. So in this case, we can let them know this kind of information in a very quick way, and let them operate their reservoir conveniently. Okay, this is a very important application when you use ODC. Okay, and another thing is for the data here, this is the original data. We call that ARD, right? But for this one, the derived data, we call it DRD, decision ready data. Because the data here is already can let your users, maybe government officers, to make decisions. So this is DRD. So DRD can also be imported to data cube and then make service to your users. This is another very important idea. Okay, so not only ARD can be handled, actually your government office need DRD. Sometimes they told me, I don't need satellite image. We don't have places to save that large amount of original data. They need the derived information can be used directly. So that is DRD. Okay. 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 Another case is for sleep. That is certain landslide activity profile. That is used to detect landslide. Actually, we have TASA has collaborated with Sentinel Asia to do disaster event analysis. And also when there is a need, the Sentinel Asia will send EOR, emergent observation request, to let us to test our satellite and acquire corresponding disaster area. And then, okay, and then we will put that in one of our modules, for example, the landslide detection, if the case is landslide. And then we will analyze where is the landslide area. For example, for this case, there is a landslide in Tajikistan, and then we take the image over there. Oh, we use the image over there. For example, in this case, that is Sentinel-2 data, and see where is the changes that is in how to say that, disappear of vegetations, and that, and also slope areas. Then the area is probably to be landslide area. So the next one, okay. Okay, so we can provide the result of the sleep area. Okay, and this is the way you're using the NS module in DataCube. But another approach is that maybe not everyone can write program, and not everyone wants to go to OpenDataCube to use to operate the result, because sometimes, as you know, you have to, not everyone can write in a code, or even not only writing, but the operate the code in the Jupyter is not that easy. So here we promote another thing, is we call that RPC, remote procedure code. That means you can use your desktop system, or local system, to send the criteria to our DataCube and ask some proper module to be process the data, okay, and get the result back to users, and then make everything more convenient to operate with China. Okay, so actually this is the case. This is the case of using QGIS to connect it to our ODC and make the analysis. Then get analyze result back to their desktop GIS. Okay, go. And as you know, in the critical time, I mean, when there's disaster, the problem normally is the data itself, not the module. Normally, the module is already there, and then we have to take our effort to collect the image right after the event. So, in TASA, actually, we make everything as SOP. When there is EOR or emergent observation request there, then we will test our satellite right away to get the image back to our ODC, and the user can send their spatial and the temporal criteria to get the density area, for example, back to their desktop. Then they can continue their operations. For example, in this case, we have a toolbox. We have a toolbox written in QGIS, and after they initiate this toolbox, they can specify their spatial location by drawing a rectangular here, and then also specify the temporal range here. Then they can get the result like this one: a previous image, another image, and the density area. Okay, and but right now we're doing this by API. In this case, actually not by API. It's calling the module by shell script. But right now, shell script is insecure. So we translate every procedure to API. And we are going to have a demo, right? We are going to have a demo in the training workshop. Yeah, next one. But actually, this is the whole scenario. Normally, for people using, handling disaster, they won't have the time to prepare the satellite images and that. So they can use our density module in our ODC and use QGIS to activate everything. And when they get the density result, they can combine their own data, for example, in this case, raw data, to find where is affected raw segment and then produce a layout for user to declare the whole thing. Okay, actually, this is a case that we cooperate with Taiwan NCDR, National Center for Disaster Response. Yeah, because sometimes users just want to have analyze data from satellite, but the rest of things they want to do by themselves. So by using the RPC code, everything can be connected seamlessly to finish what user need. Okay, next one. Okay, conclusions. Okay, open data is very useful for us, and it is a very important platform. And with the environmental Docker architecture, the security will be increased. And we already including Sentinel-1 and then Sentinel series, then the series and formula series data in ARD, and user can use that conveniently. By using a remote procedure call, the user outside the data cube can also use our facility conveniently. Okay, this is my conclusions. Yep, because we want to way more people to be here, so I talk a little bit longer. Okay, so I think it should be okay for our training workshop. It should be very easy. Okay, should we have a break right now, or we still have time?
Yeah, we have time, but it depends that because what is the next session? Just introducing to how to do it.
I think we can do that very flexible.
Okay. We still haven't have it out well. 20 minutes. Maybe you introduce that a bit. Or we can have it.
Okay.
Or discussion.
Yeah, or discussion. Yeah, we can have discussion first.
Actually, we have second part lecture over there. Okay,
Right.
你完成了20分钟内。
Okay.
Okay,
maybe you elaborate more because.
Oh, okay.
Because you are now have collaboration with Thailand, with real cases. Would you like to explore a bit more about the collaboration model? For example, the Thailand colleague could also share the GISTA data to the Open Data Cube, right?
No. Still not that quick.
I mean, technically that's possible.
Technically possible.
And it's also possible to set up an Open Data Cube system in Thailand for the Thailand people.
But that for the horticulture.
No, not just.
Right. I know, but you could extend to something else, right?
So you are mentioning that to install Data Cube in Thailand, right?
If they are interested in doing this.
Definitely. But
technically, that's also feasible.
But the cloud system can be a dual.
Although right now, Dr. Noppada use a cloud system in Taiwan.
NECTEC using in Taiwan.
But they still want to install their own own one. So right now we are discussing about this part. I think they already have one over there. But that is a local one, experimental one. The resource is not that good, but they try to install by themselves with our help.
Just like to make sure that technically it's possible to federate the different Open Data Cube in different places.
So is it for NECTEC? Is it with the Dr. Piyawut as well, like using his
Dr.
SPC?
Right now only install in the VM of their lab. Not the VM. How to say that? 实体机. Physical machine in their laboratory. So right now it's still in test stage. So eventually they want to move everything to Thai SC.
But
right now,
because he trying to find customers.
That is the play in next. I think they have talked to Thai SC and see how to facilitate this part.
As I know that Open Data Cube is also used by ESA. As a delivery of the Sentinel data resources of the satellite of the Europe Space Agency. And probably also NASA using the similar technology as well.
I think so.
I think this part is handled by USGS. NASA is responsible.
It depends on what kind of data you're talking about. It's like where everybody say, okay, this is just additional. Everybody's saying that NASA has owned the data. No, NASA launched the satellite. USGS managed the whole Landsat program. NOAA managed
the data services is sometimes collaborated.
But actually NASA doesn't they don't host the data. They're not. With big archive like for USGS, when they start Google Earth Engine started because of USGS open Landsat for free. That's why. And then the Google tried to help Professor Matt Hansen at University of Maryland because his system cannot process like a 10 million Landsat one time, so they built this and then they opened for everybody.
So similarly, I'm not sure if feels that the space agency
they also have, I'm sure,
interested in this and maybe Leon to support the Open Data Cube services for them.
So that's the thing that you have to maybe use here too. So just briefly discuss and then could be.
Actually, TASA right now is talking with Phil Sang to search this parcel.
Joel, he used to be co-chair here. Now he's the boss there. Never come again.
Okay, I think maybe we have a break right now. And back to here. 10 minutes?
11 o'clock. But I would like to know one more thing. The data that you now hosting for Thailand. What satellite? All those that you listed?
Actually, majorly Sentinel 1 and 2.
Sentinel 1 and 2.
Some of Formosat.
Okay.
Yeah, we also provide some formal data for especially for high resolution part analysis for some critical areas.
That can be request also, like if something happened and we need to look further into
right now
the specific area.
For Sentinel part is okay.
Yeah,
But for formal set part is only for no part right now.
Okay.
Yeah,
okay,
because
okay.
that
Right.
need license. Yeah.
Okay.
Yeah. But we can talk in later if somebody is interested. We can talk.
Yeah.
Because we still have time. Apart from the agriculture area collaboration with Thailand, earlier Dr. Chai also mentioned about if that's possible to have some the observation of the
mangrove.
No, wildfire.
Wildfire that
in the
we
upper
can do
ASEAN
it mangrove
region. Yes.
forest.
Yes.
Yeah. I think the wildfire is okay because I just that we have example from that part. Yeah.
Okay. Because that could be operation.
Yes.
Additional to what we have now, because most of the time they have all application. Everybody get the data from NOAA and NASA firms that we have, and then doing different application. But and in fact, it's already. I mean, they want the mobile app, but actually, it's already there. You can.
And Basuki from Indonesia
always.
also mentioned about this.
He has to talk with Lapan. He's there.
Lapan.
Yeah, he has to talk with Lapan, but we trying to help support him. But
right now, Brin.
Similar request from Indonesia.
I mean, Indonesia right now,
right.
everything handled by Brin. BRM.
Okay, because one guy I invited him, but he couldn't come. Also, they moving to under the president office. Yeah, they're changing name, long name now in Indonesia. Like, what is this? But but Basuki, always request, but sometimes like Chris Elwich from there used to be at NOAA, but now he's in my Colorado University, doing the Earth observation. He's in AIT now. Have a special lecture teaching for like maybe 2 months or something, one semester. I don't know. But I told Basuki to talk to him, because if you're using his product, you better talk to him. He will answer. So he never asked. So I sent out the email. But
maybe next time we can invite Chris.
I asked him to come, but this week they have they have land use and cover change meeting for Landsat in Vietnam. So they all go there.
Okay. By the way, when you we will have a break, and when you come back here, and maybe during the break, if you are interested to use our VM, we can give you the IP here. Okay, and then you can log on and see what happened, and or you can maybe you can better follow our practice and non-practice, something like that. So if you're interested in using our VM, you can come to her and get a IP over there. Yeah. Okay, let's have a break.
Okay, 11 o'clock.
And who want to use can go.
Come to
Yeah.